Okay, boys. I hope you're all keeping well. I hope your families are all keeping well, and that you're getting through this okay. Today we're going to do the 2019 Surface Geometry question C3. I'm going to do it in two parts so that it's very distinct. Now the traces of the plane I'm going to do separately, but the dihedral angle and the elevation plan and end view and the true shapes I'm going to do on one video, and then I'm going to do the traces of the plane on another. Now the traces of the plane is quite simple. You have to find the plane that touches both the horizontal and vertical trace, and the only way you can do that is by having a line horizontal. I'll go through that in a wee minute. So we're going to start off now. I'm hoping most of you will be able to put in the measurements as they are on the sheet. Any extra measurements or anything like that I'm going to put in for you so that you have an idea of where to work. Okay, so as you can see, I've put in the height or the depth measurements: 1, 2 meters, 3 meters, and 2.5. So at 1 is to 100, that is 10, 20, 30, and 25 mil. I've put in the height measurements of 60 and 35 there. I've put in the width of 2, 7.5 meters, 2.5 meters, and 3.5 meters. Now, so I'm going to go over this a wee bit darker to make sure that we have it in place. So first of all, I'm going to draw this triangle in the elevation. Because that's important. That gives us a key point here, which we can draw into over there. Okay, so that gives us pretty much our elevation. So now we can see our elevation was fairly easily done. Nothing too complicated than that. Now our plan. So what we have to do here is come down 60. Draw a line across, it hits this middle point here, and create a surface there, which actually turns out to be the surface C, which we will use later on for the true shape. We must bring down this point. And we must bring down this point because this here has a key component too. We'll join this point over to here. Now that is our plan drawn. So the next surface I'm going to draw is the surface A, but before I do that I'm going to bring these points here, which were not in the original drawing, over to hit here. And bring them points up. Okay. Now I'm going to draw the surface A where it should be. Okay. Now we're going to draw the surface B. So the surface B starts here. And it goes up as far as there. So B is in there. Up in there. last surface we need to draw is this surface here. So we draw it across to the point. Bring this point across. Bring it up. Okay, so that is the elevation plan and end view complete. Again, wasn't overly complicated. I hope you were able to do that okay. Now, part B of the question says determine the dihedral angle between the surfaces A and B. So the surface A is this edge here in elevation, and this is the surface B, but in plan it's this surface here and this surface here. Now, the first thing we have to do is determine the line of intersection. So I'm going to mark that in clearly in blue so that we can see it. This is the line of intersection. Hope you can see that that's in blue. And here is also the line of intersection between the two surfaces. So I'm going to call that the LOI. LOI. Now, you don't need to do the whole two surfaces, because if we do the whole two surfaces, we're going to end up with 1, 2, 3, 4, 5, 6 points. Now, what I'm going to do is I'm going to draw an angled line down from the top corner here. And when I draw that line down, it's going to give me a point here. Now that's going to turn it into two triangles, which means we're going to reduce the number of points that we require. So I'm going to reduce that down, make it a wee bit smaller and make it easier to work. So I'm going to turn this into two separate planes. Okay, but the planes are going to be triangles. So if I look down here, I'm going to project that down in plan. That is creating a plane, a triangular plane, which means there'll be less work involved. Okay, so I'm going to highlight that plane in the light color. So I'm going to put a wee mark on it. And that's that plane there in elevation. Okay, so we're going to call this point here, the line of intersection, we're going to call it 1, 2. We'll call it 1 and 2. Now, you can only see one plane at the moment, and that is the purpose of plane B. Okay, so what I'm going to do here is with that line of intersection, I'm going to join another line from here, from 1 down to this bottom corner. Okay, and that'll give me another triangular surface. Okay, but you can't see that because that's an edge view of the surface A. Okay, so when we're doing the dihedral angle, we have to look at it to get the line of intersection as a true length. And once we find it as a true length, we have to look along it to turn it into a point so that it becomes a sort of hinge. And from that hinge, we should be able to determine the dihedral angle. So I'm going to call that 0.4. So that also becomes 0.4, and that's 0.3. So now we're going to take down 4 points instead of 3 points, and our object is going to be much smaller and take up less room on the page. So I'm going to project it from the elevation, but you can project it from the plan if you wish. It doesn't matter which way you do it, as long as you see it as a true length. Okay, so as long as you see it as a true length, that's all that matters. Now, anytime we're doing a dihedral angle, you have to start off, to determine the true length, you have to start looking at it and then along it. There's no other way of doing it. Okay, now because 4 is a horizontal line, I'm going to start all my measurements from there. So 4 is going to be on that point. So here's my point 4. Now, point 1, I'm going to measure from the same line. As you can see, I'm going to go up to 1 and measure that distance out. I'm going to go to 4 and measure down to 2. And measure out to 2. Now remember, when we're doing this here, that we are always going 2 steps back to draw an auxiliary view. So from here, that's 1 step to the first, 2 steps back. So in that regard, we should be able to determine very quickly where we're at. So it's, you only ever go 2 steps back. Now that we found the true length, so this here blue line now is the true length of line of intersection. Okay, now we must look along it. So we're going to send out these points at 90 degree, or looking along it, so parallel to that point. So I'm going to send out the point 3, point 1 and 2, and the point 4. Now, this is x2, y2. Now, because this here is going to be a new auxiliary, we're going to go back 2 spaces. So we're going to go back 1, then we go to the previous xy line and measure from there back. So as you can see, from there to 1, 2, and 4 is all going to be the same distance. We really only need the distance for 3, but to clarify the points, I'm just going to go and measure from x1, y1 back. Okay, so there's 4, there's 1 and 2. The last point I need is 3. Okay, and now that will give us the dihedral angle, and our line of intersection, because we look along it, becomes a point. So as you can see, that would sort of look like a hinge. Do you understand? Okay, so that there now is our dihedral angle. Okay. Now, I hope you've all understood that. We've done that numerous occasions before, and I hope that you all found that useful. Right, quite quickly we're going to go on to the true shapes. And to determine the true shapes, you have to see it as an edge view. Now, our surface C here, so I'm going to mark in pink. In elevation, we see its heights. In plan, we see it as an edge view. So I'm going to highlight the surface C in pink. Now, because that there is a horizontal or a straight line and there's no movement on it, all I have to do is look at it, because what we're trying to do is to try and get an edge view of the surface to try and draw the shape. So in this case here, we just have to look perpendicular to it and take the heights from our elevation. So I'm going to go and do that now. Project out the points. So I'm going to label them points so that you can see where we're going. So that one there is going to be 5, 6, 7, and 8. 8, 7, 6, and 5. Okay, now 8 and 5 are on the ground line, so they will start there. 6 and 7 are the only 2 points that we need to take down. So to take down 6 and 7, that is 6. Take down 7. And that will complete our surface C, the true shape of our surface C. Now that was fairly easy now. I hope you all understood what we done there. But that is the true shape of our surface C. Now, okay, so that's C done. That's fairly simple again. Now, surface B is a wee bit different. Surface B is different in the fact that it's actually sloping back towards us. Okay, so it's sloping away, actually sloping away from us. So what we have to do is find an edge view of that, rabat it around and bring the points back across to get its true heights. Okay, so that's what we're going to do. I'm going to show you how to do that now. So this is a horizontal line. Because it's on the ground, we know that it's a horizontal line. So everything we can do is going to be perpendicular to that. So for the rabatment, we're going to bring out that point, which is 2 and 5. We're going to bring out that point, and we need to bring out the point 1. The point 1. And we need to set up an XY line at 90 degrees to that. Okay, so this is our point. You can see this here, 2, 5. Now I'm going to bring out the height of 1 measured out there, and that is the true angle of inclination. So that's its true angle of inclination. Okay, so from there, that's an edge view of the surface B. So that's an edge view of surface B. This point here is 1. No, this is 1, and this here is the point 6. Okay, so now that we've got that completed, what we're going to do is we're going to rotate them around, them points round, and bring them straight back up. So we're going to rotate the point 6 to here, and the point 1 to here, and we're going to draw these lines up. So I'm going to project out at 90 degrees to the line 2,5 from 1 and from 6. So because this is a horizontal line, everything we're going to look at is either 90 degrees to it or horizontal to it. So we now will complete that surface by drawing 5 to the point 6, 2 to the point 1, and that is the true shape of B. Okay, so just to recap on that, because that's a horizontal line, we could look along it to get an edge view. You always need a horizontal line to get the true inclination of something. So when we brought that point down, we brought it up to get its edge view. We rotated it around, which means we rotated it around the points 2, 5 because they're on the ground. So 6 was rotated round and 1 was rotated round. That's called rebattement. And when they're brought round, they were brought straight back up parallel to the line 2, 5. And then each point was brought in at 90 degrees to the line 2, 5, or perpendicular to the line 2, 5. Now that is A, B, and C done on question C3. But as you can see, the page is quite full. So I'm going to now stop this video, and I'm going to draw out the shapes again. I'm only going to draw the elevation and plan, and I'm going to show you how to do the horizontal and vertical traces. Okay, thank you.